Okay, welcome to the last session of SLE. So this is a session on tools and demonstration. Well, this is a conference on engineering, so we'd like to build tools to make useful things. And we had an invited talk about no code, and this one is about low code. Okay, so please go ahead, Jérôme.
Yes, hi everyone. I'm Jérôme Pfeiffer. I'm from the University of Stuttgart, and I'm happy to present today to you a low-code platform for the systematic component-oriented language composition. First, I will present some motivation and background on the underlying concept, and then afterwards I will tell you about the low-code platform itself and give a short demo, and at the end I will discuss and conclude. So, as we know, domain-specific modeling increases abstractions and thereby also increases productivity. For instance, this article here created web applications using a DSL, and it was less than 20% of the effort than performing the work manually. For us, textual external DSLs require three definition artifacts or definition dimensions. First of all, the syntax, describing how the models appear. Our concept bases on the syntax definition in grammars. Then we have well-formedness rules that constrain the models of the language, and we have semantics that define what the models mean. So, in contrast to the efficiency of DSLs themselves, their reuse is still complex and inefficient. That's because it requires a lot of white box knowledge. For instance, when combining two languages, you have to care about how the syntax, the well-formedness rules, and also the semantics are realized, how they can be combined in detail internally in the respective technological space. And you also have to know how to parameterize the composition operators, and you also have to know what is the result actually when composing two languages. Because it is so complex and inefficient, we oftentimes tend to ad hoc develop new DSLs from scratch or don't use DSLs at all. Yes, and to facilitate this reuse, we applied component-based software engineering to software language engineering and encapsulate language constituents into language components. These components have a defined interface and thereby make the internal definition artifacts of the DSL explicit via extensions. We differentiate between provided and required extensions. Provided extensions provide language concepts to other language components to be reused, and required extensions make the need for integrating language concepts explicit. And then we can combine languages by plugging these language component interfaces into another. On top of this language component definition, we also developed a method to systematically compose these components. We have this notion of DSL families that are a product line of languages that where each feature in this product line is realized by a language component, and the features also define how the components are combined. And then a DSL owner, can select features from this language family and derive a language variant. Yes. So from this concept, we designed a low-code platform, and it's an associated language reuse process. So we stay building languages with a language workbench of our choice. In our work, it's Monticore for now, where we still have these three dimensions of language definition. then our platform should enable to import existing projects, language projects, and automatically derive a language component notation from it. Then we want to have a library functionality to like browse through existing language families, existing language components. We also want to define new language families, and we want to be able to configure these language families to derive new DSLs. And ultimately, we want to export our composed language and use it, of course. So, the software architecture of this low-code platform is a classical three-tier software architecture with a front end, which in our case contains 4 UI components. Then we have a back end comprising a controller, which does the user management, data access. And at the heart of the back end, there is our Scholar framework, which is decomposed into 2 software components. One, the language family tool, is responsible for processing language family models and guiding the composition process along the feature tree. And then we have the language component tool, which is able to process language component models. And we also have made it extensible to not be restricted on Montecore. And therefore, we have these green components that are extensible with other technological spaces. So basically, the artifact composition might be different in other, or is different in other technological spaces. All right, then let's jump into the demo part. Yes, first we log in, of course. Then we get to the main menu with the language workbench, no, not the language family workbench to build new language families, and then the 2 libraries for viewing existing language families and components. In the component library can view and also import new language projects. So after importing the project, we can configure its extension points. So in this demo, we want to develop a state chart family. So right now we are importing a basic state chart project, language project. After configuring it, it's available in the library. You can click it and see what's contained in it. Or what its interface looks like. Next, we want to create a new language family. For this, we go into the workbench. Here you can decide whether you want to create a new language family or you want to open an existing one and update it. So we want to create a new one. And in the first steps, you basically build up a feature tree. So we start with the root feature state chart, and then we want to have transitions, right? And we also want to have some kind of guard, and then you can define the connections between the features to build up the tree. You can use the well-known relationships available in feature models. Yes, and after you created the feature tree, you can connect the features with the language components from the component library and bind the constituents of it. Here we bind the production rules, and we will now jump into the finished language family and configure it. So we select the features by just clicking them, and then we push the button derive DSL. Then we export the project as a zip file. Yes. Yeah, and then we can just unzip it and yeah, have the composed language in our file system. Yeah, here you can see the composed grammar. I think it's a little bit too small. Yes. All right. Limitations for now are that projects have to adhere to a specific structure. They have to be written with the language workbench Montecore. So we are restricted to the syntax definition in Montecore. We are using code generators for the semantic mapping. And also we are restricted to the language embedding and aggregation composition operators. And in additive language composition in general. In the future, we want to improve the error reporting and general stability of the platform. We also want to integrate LSP generation to make the composed languages more usable and also make them containerized so that the users who want to start modeling can have a low barrier to do so. We also want to support X-tags and more composition operators, of course, and we also want to perform a user study and evaluate it with further case studies. All right, then let's conclude. We've seen a low-code platform for language composition, which supports the import of language projects from Montecore right now. You can configure the automatically derived language components. You can view them in the libraries, also the language families. You can create new language families, and you can configure them and thereby export language variants. All this requires no setup because it's web-based, and it's also easy deployable because it's containerized app. Yeah, and on the right-hand side, you can scan the QR code to rewatch the screencast. Maybe you can read also then the end part, and you can scan the other QR code to read the paper and get more details. All right, thank you.
So we have time for questions. Yes, please, Eric.
Hi, thanks. I was curious, you said something about error reporting. What kind of things can go wrong in the composition? This was your future work with something about more error reporting or better.
Yeah, I mean, maybe you can derive, or you can configure in the language family, you can configure erroneous configurations that are not allowed by definition of the language family itself. So the feature diagram.
Okay, so some components would not work with other components, and that would be something you have to navigate.
Yeah, right, this too, yeah. And also for the import, we don't check the folder structure, it just gives a cryptic error, and we could improve that.
Yeah, I guess I guess sort of what is sort of substantial things that are errors as opposed to implementation level details of things that are just nicer and prettier. But the point I guess I was asking is that some things are meant to work together and some configurations are not.
Yeah.
Yeah, okay.
You have a question? So I have a question because
yeah.
One of our biggest companies in Portugal, OutSystems, developed the low-code platform that is used worldwide, and they are coining this term. And so, have you considered to use that platform to implement this language composition? Because you built it specific for your.
Yes.
text.
No, I built up the app from ground up, so I didn't use a low-code platform to kind of bootstrap this this low-code platform. So no, did not do that.
So okay, so it's like picture again.
Yeah.